Hi everyone, so in this video I'm going to show you how to integrate with hyperbolic functions in the form of 1 over and then the square root of a quadratic. And to do this we're going to use the standard integrals of this form. But to make this quadratic look like an x squared term minus a constant, we need to use the method of completing the square. So we're going to begin by completing the square of this quadratic, where we have x squared plus 6x minus 7. And when we complete the square, we get x plus 3. So this 3 is half of the 6. We'll create this into a square. We'll complete it by taking away the 9. And now we have this bit, and we'll take away the 7. So we get x plus 3 all squared minus 16. And now we have this in this form, an x term squared minus a constant term. We can write this back into our integral. So we've got the integral of 1 over the square root of x plus 3 squared minus 16, all integrated with respect to x. So now we can see this x plus 3 will map on to our x term, and this negative 16 will map on to this a squared term. So a squared will equal 16, which means a must be equal to 4. So now we can use this standard integral, where we have the r cosh of x, which is x plus 3, over a, which is 4. And then we'll add the constant of integration. Okay? I hope that's given you some idea on how to integrate functions such as this. In question 2, we're going to take it a little bit further. Okay, so in question 2, this is a bit more difficult because the coefficient of x squared is no longer 1 or no longer a square number. So before we can use completing the square, we need to factor out this 2. So we'll write 2x squared plus 8x plus 5. We'll factor out the 2, so we get x squared plus 4x plus 5 over 2. And then we'll complete the square of this. So we get 2 lots of x having this 4 to get 2, all squared. Complete the square by minusing the 4, then we have to add back in the 5 over 2. Negative 4 plus 5 over 2 is minus 3 over 2, so minus 3 over 2. And then we'll put this back into our integral. So it'll be the integral of 1 over the square root of 2 multiplied by x plus 2 squared minus 3 over 2, integrated with respect to x. So we can see it's not quite in this format just yet because we need a 1 here and we've got a root 2. So we can pull this 1 over root 2 out in front of our integral. So it becomes 1 over root 2 times the integral of 1 over x plus 2 squared minus 3 over 2 all square rooted. So now this x term maps onto x plus 2, and this a squared term is 3 over 2. And if a squared is 3 over 2, then a must be equal to root 3 over root 2. So now using this standard integral, it will be 1 over root 2 times the r cosh of the x over a, so root 3 over root 2. We can simplify this fraction by multiplying everything by root 2. So we get 1 over root 2 times the r cosh of root 2 x plus 2 over root 3. plus the constant term. Okay? So I hope that's given you a clearer idea on how to integrate with hyperbolics where we have a quadratic denominator. If you did find this tutorial helpful, please hit that like button and share it with your friends, and don't forget to subscribe for more further maths and GCSE video tutorials. You can download the full lesson and worksheet from my website mrmathematics.com. There's a link in the description below.